Welcome to the CAM Tool Quick Start tutorial. This tutorial is designed to give you the steps required to process an average job and to teach you some very simple tool pathing. It assumes that you know already the icons and mouse movements. So let's get started. First, we'll need to open a file. We'll go to File, Open, and we will navigate to C, CAM Tool Data, CONV, Sample. You'll notice that it's looking for type GMD, which is a model file, so we're going to switch it to look for an IGES, and we'll see there's an IGES sample. Let's use that and open it. First thing we should do is save this file, so that way the software knows where to paint any additional folders and where to put your toolpath. So what we're going to do is we're just going to save that on my desktop in a training folder. All right, we're ready to begin. First thing we're going to do is reform the surfaces. Why reform? Well, many other softwares use a lot more data to represent those surfaces than what CAM Tool really needs. So by reforming the surface, it gets rid of any of those extras that CAM Tool doesn't need and makes the file a little more CAM Tool friendly and usually decreases the model size. So let's go to Surface Shape, Verify Surface, Reform Surface. We generally use a tolerance of 1/10 for reforming surfaces. So now we're going to window the geometry and use our middle mouse to execute. Anytime you get lost in CAM Tool, you'll notice at the bottom of the screen there's a command prompt telling you what it's looking for. So it gives you a sort of a roadmap as to how to use these commands. So after reforming the surfaces, now we need to make sure there's no errors. So we're going to check these surfaces. So we'll Surface Shape, Verify Surface, Check Surface. And again, we'll window the geometry and press our middle mouse button to execute. Now you notice we've got some issues going on with this model. Typically, we have two repair commands that you run on a model. And if they don't clean up all the issues in the check surface, then we just move on. Unless, of course, that there's something that says warning or error, and that may be something that your engineering department will have to take a look at. So right now, let's take a look at those two correction patches that we have. So we'll Surface Shape, Verify Surface, Correct Surface Patch. And again, we'll window the geometry, tell it we want to look at everything, and we press the middle mouse to execute. So let's run the second command now. Verify Surface, Correct Surface Contour. Window our geometry, and depress the middle mouse to execute. You'll notice that an error appeared. Let's take a look at that. It's saying there is no surface to be corrected, so that patch wasn't required by this model. Let's take a look and see if there's anything left to fix. We'll go to Surface Shape, Verify Surface, Check Surface. Windows Geometry, and depress the middle mouse. Now in this case, the two correction patches corrected all the issues with this model. That's not always the case. But as we were told earlier, is that not everything on this that this detects is going to be an error. Some things just maybe slow down toolpath creation or things like that. Not necessarily something physically wrong with the geometry. If it says warning or error, then obviously you're going to have to do something to fix it. Usually getting your engineering department involved at that point would be a good idea. If we use the Select None, it'll clear off some of these boxes that we don't want on the screen. Sometimes even Escape will work. Now we need to move all of our model surfaces to Layer 1. CAM Tool has 255 layers available to use for geometry, and we can look at them in this Browse Layers button. And you'll see that it displays the layers that are geometry on them and the blank ones. Each of these layers you can give a name or a label to tell what you use that geometry for. As you can see in this particular case, we have surfaces on layer 1 and on layer 50, and we want to merge everything onto layer 1. So what we will do is we'll go Edit, Move Copy, Layer Move Copy, and we'll set it to Move, and we want to move everything to layer 1. So highlight our geometry, and depress the middle mouse to execute. Now when we go back to our layer browser, you'll see everything has been moved onto layer 1. The reason that's important is that what we're doing is we're going to create basically a template idea so that if you always put your geometry of certain types on the same layer, then your toolpath can be recycled from one job to the next. CAMTOol has a great feature under CAM environment called Auto Shape Setting. Here you'll see different types of surfaces that are used within the toolpath commands and a layer assignment next to them. As long as you put, say, surface to machine always on layer 1, then any toolpath that uses that surface to machine will automatically select the geometry on layer 1. So the software actually gets smarter the more information you give it about how you want to make your toolpath. For this demonstration, what we're going to do is we're going to use layers 1, 10, and 15. Layer 1 for the geometry we want to cut, layer 10 for our stock model surfaces, and layer 15 for our calculation boundary. Now, if we want to make geometry directly on a layer, what we have to do is use this window right here. This is called your active layer. Whatever number you have in here, that's the layer number new geometry will be created on. So we've set it to layer 10, and we're going to create the surfaces we need for our stock model. To do that, we're going to go to Surface Shape, Cube, Boundary. And again, we're going to window our geometry and hit the middle mouse. You'll see that it forms a cube with exactly the same shape as the geometry that we had selected. And when we look in our layer browser, you'll notice now we have surfaces on layer 1 and layer 10. So now let's make our calculation boundary. So we want to put that on layer 15. So with layer 15 set as active, now we go to Surface Shape, Finite Plane, which is Flat Plane, Rectangle. And we're going to create a rectangle that's going to represent the full size of the stock. So that we say we want to cut everything inside of that. So as we move our cursor over a corner, you'll see that it snaps to the intersect point. Click there, and then you'll notice that it drags a box. As soon as you reach another snap point, the box automatically snaps there. So drag your box to the opposing corner and click. Now, you'll notice in your layer browser we have surfaces on layer 1, layer 10, and layer 15. We're ready to move on to the next step. What we need now is we need to create a process list. Now, a process list is something where your toolpath definitions are stored. It's like an envelope. Or if you work with other softwares, maybe a process manager or operations manager or that such kind of thing. It basically just stores the definitions of your toolpath. Now to do that, it'll be under the CAM menu. Go CAM, Calculation Process List, New. And we'll give it a name, something specific to the job. You can choose that on your own. For this one, I'm just going to call it Model 1. And you'll see our process list window appears here. All your toolpaths that you create will actually end up in this process list. And you'll see the name of it down below, Model1.gc2. As well, you'll notice now you have a tab for your model that says iJustSample.gmd. In one session of CAMTOol, you can have many different models open at the same time and many different process lists, and choose them by selecting on the tab that's associated with them. Okay, so we've created our surfaces that we want to use for a stock model. And these should represent as closely as possible the stock on your machine, so the CAM tool can go through and delete error cuts and collision check properly. That's basically all the stock model is there for, is to do your collision checking and to decide what's already been cut so you don't overcut things. So we're going to create a blank stock model. So CAM, work, new. And we'll give it a name. Since it's actually just stock, that's what I call it. I just call it stock. And because I have geometry that I want to represent that stock, I'll select work shape and say OK. You'll notice now a control window shows up on the right-hand side of your screen with the work tab already open for you. CAM tool uses an average of 2,048 pins by default to represent your work. Those pins are divided down to 4 thou pins, so 4 thou by 4 thou to represent your part. If your model is too big, it'll tell you that 4 thou pins aren't big enough to represent that work, and then you will have to make them larger. These pin sizes have no bearing whatsoever on the tool path accuracy. They're only there for deleting error cuts and for your collision checking. So first we'll go into our work, and we'll click on work, and we'll tell it what we want to assign as our work geometry. So we'll go over and touch on the cube. Select the cube, and depress middle mouse to accept. Now a check mark will appear. If you end up in a situation where it says that you cannot meet that size of model with the size of pins you have, you can use the first icon, Edit Condition, and just click on the Mesh Width button, and it will automatically default to whatever the minimum size pins you can have. Pretty simple. Okay, so now we have a process list, but the two of them are still separate. We need to get them to talk to each other. So we're going to do this register and process. What that does is it tells CAM tool to use this stock model to run all of your tool paths against to make sure they're okay and for deleting error cuts. Now at this point, we're actually ready to start making some tool paths. Congratulations. We're just going to make some very basic tool paths for this job, and it'll give you an idea of the things you can do, like some recycling tool paths and copy and paste and whatnot. So first thing we're going to do is we're going to go to CAM, Profile, New. A profile is a tool path. And we're just going to go to Z-level roughing. We'll just call it R1. Now we can load tools from our tool database. By hitting loading, you'll see the tooling database come up. What we're going to do is we're just going to choose a 10 millimeter ball to rough this all out with. We need to select a specific length. We'll just go with the one in the middle. And down here we can choose a material hardness and what type of cut it is. Is it rough, finish, semi, finish fine? So we're going to go down here and we're going to choose the softest material, and we're going to choose a rough cutting pass. This will automatically adjust your speed, feed, step over, and step down for that tool for roughing application. We're almost done with the tool now. The only thing missing is a holder. So we'll go to the holder tab. And we'll just choose any tool holder that we want. Now, if we want to adjust how far the tool is sticking out of the holder, we would do this here with the protruding length. Okay, so our tool is now selected. So we can hit Finish. You'll notice that the surface to machine and the tool path boundary are already selected for this tool path. That's due to the auto shape setting that we talked about earlier. So now all I need to tell it is the Z cutting range, which is here, and I can pull down the little arrow and say coordinates. Say I want to start here and end here. Now let's go take a look at the conditions inside this tool path and see if we need to make a few changes. You notice most things are already filled in, because the tool database takes care of all of that. It gives you all the speed, step over, step down, so the toolpath has very little interaction that's actually required to make a good toolpath. The only thing we're going to do in this case is because it's a ball nose cutter and we're roughing, it's going to leave some pretty big scallops. So what we want to do is we want to adjust that on the precision page with this command, process remains. Basically, by clicking these three dots, we'll enter in a scallop height. And then anytime that the tool path goes beyond that scallop height, it'll come back and make an extra pass to clean those up. So you end up with a consistent scallop of a specific size over the whole job. We're just going to set this to 1 thou for now because it's a roughing pass. And then we can hit OK. Now, tool path is created. We'll go here and say Optimize All because we want it to run through the optimizer. And then obviously checking against the stock model. And we'll hit Start. There, now that toolpath is calculated, you notice the calculated side is saying normal, but on the optimizer there's a warning. To find out what that warning is, we can right-click on the warning and say, Show Optimization Error. And it's telling us the protruding length must be more than 1.871 inches, so our tool isn't sticking out far enough out of the holder because the holder is interfering with the material. So we need to go back in and change that. So we'll go to the second icon, which is the optimization condition sheet. And we'll just change this field here. You'll see it's sticking at 1.728. Let's just make it 2 inches. Then we know it's going to be sticking out far enough. And now we can re-optimize it again. Once it's optimized, there's a lot of different ways that we can look at this toolpath and display it. So we're going to go over a few of those things to give you an idea of what CAM tool can really do. First of all, let's double-click on the toolpath to take a look at the raw toolpath itself. And you can see it only cuts where we want it to. Some nice, neat, even passes. But what does that really tell us? If we want to actually see the toolpath running and be sure that it's running properly, what we can do is we can right-click and choose Animation. From the animation screen, we can just hit our play button and watch the toolpath run. We can speed it up here by choosing the minimum length per step. We'll just set it to 0.5 for now, just to get it running a little bit faster. And we can see what the toolpath actually looks like while it's cutting. Notice it even shows the material being removed and everything. So here we can verify that our toolpath is running the way we expected. Let's go back into the CAM tool. Now, once you've done that and you've verified that the toolpath is running the way you thought, let's take a look at what the resulting stock model is. Because CAM tool runs this toolpath against the stock model, and then we'll display a representation of what the stock should look like when the toolpath is done. In some cases, that representation might be a little crude, but it gives you a good idea of where the scallops are and what amount of stock is left in corners. So to do that, we would say Show Solid Work. So in the Show Solid Work, we can see this wireframe representing our model. And if we want to, we can shade it up, and it will give us a good representation of what our stock model looks like. As you can see, it's got some pretty big scallops, but down in the floor areas, the scallops are much smaller. So this gives you an idea of what the representation of the work actually is going to look like after each toolpath. Okay, so we've done that. Now, what I want to do is I want to make a copy of this toolpath, and I want to use a smaller size tool so I can show you how that delete air cuts works. So we're going to right-click on where it says Profile, say Copy Process, and we'll call it R2. And OK. So then we can right-click on it again and say Edit Capitalization Condition. Here in the bottom corner, we can load DB. And we'll load our tooling DB again. This time we're going to choose a 6mm bowl. And again, of medium length. And again, with a rough parameter. Now, since we know it needs to be sticking out 2 inches, we'll make that right off the bat. And we hit OK. And OK again. It's telling us we need to change the lat volume for our process remains. So we're going to go into the Precision tab. I'll just zero it out first, and then make a new cusp height of 1 thou. After that toolpath is ready to rock and roll. So we can hit the play button to start it calculating. Now, because CAM tool can calculate one toolpath per processor, we don't have to stop and wait for that one to be done. We can move on to the next toolpath. So the next toolpath we're going to look at is going to be a Z-level finish toolpath that we're going to use for semi-finishing. So we'll call it Semi-1. And go next. And we'll choose the tool database again. Now we'll go back to that 10mm tool again. Again, medium length. This time, we're going to choose a semi-finish. And let's pick a holder. And stick it out 2 inches. And we can say OK to that. And finish. As you can see, surface to machine has already been selected, and so is our toolpath boundary. Again, all we need is our cutting Z range. So we'll set our coordinates. Start here, end here. Now we can go into the toolpath and take a look and see what's in there. First thing we see is we want to set this to cut the low-lying areas. So we're going to set it to Perform. We want to change our stock to 2 thou. And let's see, anything else? Everything else seems to be okay. The only thing I would say is that we don't really want to start right at 0. We want to start a little below the parting line. So you might set it to minus 10 thou. And say OK. And you'll notice that toolpath is now there as well. So we can optimize all and let that one go. Now we need to pick out the corners because that tool is obviously a little bit too large for some of these small corners. So let's go into CAM, Profile New, and we're going to select a remachining toolpath. Remachining will sharpen corners. It doesn't rough anything, but it sharpens your corners and can run either in a Z-level fashion or along the ridge line, which makes it for very quick run times when you got it at the machine and makes for a very nice blend in your corners. So we're going to call this Semi-1, or Semi-2. Next, and we'll choose the tool database again. And we'll choose the 6mm ball one more time. And again, we'll choose our semi-parameters. We'll put a holder on it. And change it to sticking out 2 inches. And say OK. And finish. Now, the surface to machine and toolpath boundary are automatically selected. What we need to do in here is, first of all, we have to tell it what size is the last tool used. Well, the radius of the last tool used is 0.19685. Let's just call it 0.2 to be safe. You'll notice here we have something called remain step. What remain step does is that if it encounters more than this amount of stock in any corner, it's automatically going to put in an extra pass so that you don't overload your tool. That's what makes this tool pass so special, is that it will automatically stop you from overloading your tool and squawking in the corners by putting in these extra passes until it's safe to go in size for size. So then we also want to change the stock to 2000 because it's a semi as well. So we can say OK to that. And again, we'll hit Optimize All and let it go. Now, while this is going, let's go back to that second rough cutting program. Remember I was talking about delete air cuts earlier on. So if you double click on the calculated toolpath, you'll see that it calculates everything. Well, we obviously don't want to cut all that because we just got done cutting it with the first program. But then, when it looks at the stock model, it sees what's already been cut and gets rid of what it doesn't need. And this is the toolpath it actually generates. So you can see Cam Tool can actually save you an awful lot of time because it never cuts what it doesn't need to cut. It's either wrapping into a cut or wrapping out of a cut. Let's take a look at our Z-level finish semi-finish program. You'll see that it's tidying up the scallops nicely there. And now, let's go look at that remachine that we just did. You notice that it only goes where it needs to go. It only goes in the corners. And if you look here, you see that it puts in these extra passes so you never overload your tool. Very important to use the remain step when a tool hasn't been into that particular corner yet. Once it's been in, then you only have a little bit of stock left, so it's okay to remove that remain step so that your tool path runs a little faster. Well, since we've already done a finisher and a remachine, we can just copy these for our finish programs. So if we right-click on F1 and say Copy Process, we'll call it F1 for Finish. And our remachine, if we right-click on Semi 2 and say Copy Process, we can make this Finish 2. So let's take a look at this first toolpath, our Z-level finish. Right-click, Edit Calculation Condition. Well, since we've already been in there once before, we know we don't need the stock there. We're going to go right to 0 now. And we still want it to perform all those low-lying areas, but we'd like it to be a little less rough. We'd like the scalp to be consistent. So we use something called offset cutting. Offset cutting enters tangent to the surface it's cutting and exits tangent to the surface. So it's sort of like it's dusting on those extra moves to make the scallop consistent between your walls and floor and any low-lying areas. Creates a near mirror finish. So let's say OK to that. Well, that one's ready to go. Now, let's right-click on our Finish 2 and Edit Calculation Condition. Well, the radius of the tool hasn't changed. It's still going to be that 10 mil tool. But since we've already been in there once, we don't need this remain step, so we can make that 0. And since it's finished, we can make our stock 0 as well. And that's all we need to change. So now let's select all the toolpaths and send them off to calculate. If you want to select all the toolpaths, right above the number column there's NO period. Click on that box, and it'll select them all. And then we can just hit the play button and say yes subsequently, which means yes do them all. But because the last toolpaths are the only ones that actually needed to be processed, that's all it's going to do. And when these are done, we can take a look at what the final result of the toolpaths is. Okay, so our toolpaths have finished up now. Now what we're going to do is we're going to take a look at them. The Z-level finish first. And we can see, if you look there inside where it's putting in these extra passes in with the scallops to make it a more true mirror finish in the bottom, so it's not stepping over quite so wide. But let's take a look at the stock model of that. So click on it, right-click on the normal, and we'll say Show Solid Work. Okay, when we take a look inside here now, we'll shade this up and see what our finished model looks like. Well, you'll see that we still have a spot left here where the remachines have to go and clean up these corners, but the surface finish looks pretty nice all over. So let's go back and take a look at that remachine toolpath. So if you double-click on the remachine, you'll see that since we don't have a main step, it's not putting these extra passes in the corner anymore. And it runs ridge line where it can. So it makes for a very pretty toolpath, and it runs very smoothly. Let's take a look at the solid model that completes this whole job and see how we did. So we'll go right-click and Show Solid Work. So now let's see how we did here. Let's shade up this stock model and take a look at our final part. If your file looks like this, you did it right. If you need any further information or would like to obtain the 10-step document that accompanies this video, get with your sales rep. They'll be happy to help you. And happy toolpathing.